Hello and welcome to our first Project Spaceship live event stream. My name is Christian and I'm your host for the next hour or so. And I'm going to explain you a specific type of propulsion solution, which is more or less um, imaginative. So it's a mechanical way to propel objects, um, which is very used in the past for, yeah, imaginative drives that we can use on rocket and spaceships. And yeah, so we are going to see today some historical yeah, trials of inventing such a mechanical drive. And we are also um, will have a look on experiments we did as a side stream, so to say, of the project spaceship activities, because it's very interesting to have such a drive that can substitute rocket engines in a regular way, because rocket engines are, yeah, massive. They need a lot of fuel and oxidizer. And this is, of course, a constraint if you want to have a long-term spaceship and if you want to do deep space missions. So why do we do this event today? So the idea is to share my thoughts about such a drive, even if it's imaginative. So I know from a physical standpoint, a pure mechanical propulsion of a spaceship in free space is not possible. I know this, and I did my research always with the background. Okay, I know I cannot expect something, so it's fine if I end with no result. Um, but I thought it was good to think out of the box, yeah, to not to be with the streamline, to put rocket engines on a spaceship and something like this, which I usually do. So my normal publications are based on the regular solutions, which I know that they are working and that you can plan missions with them. Um, but in parallel, I would like to know if there maybe is a solution that could go in a different way. And maybe we'll have also some results that are interesting at least. So let's see where we are at the moment. We are here in my little tiny studio. So this is yeah, a little room, 2 by 2 meters. And yeah, so here in this room, I'm doing most of my research work. So it's a silent place. I can stay here and can work on my publications, can work on my research. And so yeah, today invite you in this little space. Today, what we want to do as next is we want to think about how could we do a propulsion based on mechanical principles. So we want to have first a view to the past. I found a very interesting video um, that more or less introduces the basic concept or the basic principle of an pure mechanic drive. Then what I did next is I tried to prove this concept, because in on the online world you can find more or less everything, but yeah, it's good to know that it's really that what you see. So a result that you can see. I want to prove this by myself. It's okay, or if it's not okay. And based on this knowledge that it's working and more or less how it's working, I try to do my own experiments. And one of these experiments, just let me introduce my pointer here. So here it is. So one of these results and one of these experiments I made is an horizontal experiment, in which I modified the basic principle a bit and tried to create a force that is moving forward a construction. Uh, and so I analyzed this more or less, how this forward movement is working. and how I could also improve it for a second time. And this is what I made for the second experiment I made, because here I turned this object, this construction, by 90 degrees and tried if I could reach also a lifting force, so that in reality maybe we can use such an engine to lift an object from the earth and to let it fly. Of course, in the background, I always had in mind this should work also in free space. So there is no air around it. So there's nothing it can push on. So it really is an inert system at the end. And yeah, we will see what results I found. First of all, I want to go a little step into the past because I found, as I said before, a little video. This video is from the 50s, and you will see a researcher. Um, that name I was not able to find out. But this researcher made a solution that is really interesting. So just let me switch the screen. So you see here a little car. And this car has some wheels, and these wheels are not connected to something, so they are free spinning. And if you put it here on the surface, you see the car is moving in steps. And so here you see the inner of the car, which is a car inside the car. You see, the inner car is moving forward and backward and is pushing the car below piece by piece into the front. And you see also here two pendulums that are rotating contrawise. And so by this pendulum movement, the inner car is moving. So everything is more or less related to mass movements. So there is no wheel driven or something like this. And this makes it special for me because it's something that might indicate that there is a drive that is really maybe able to work in free space. Yeah. Just let me restart this video that you can see it again. What is also very noticeable is that these pendulums have an inclination. And this inclination is something that is really relevant because the inclination itself, you see here the inclination, I just see it here, and the card moves back and forward. Here the inclination. And this inclination, I found that it's really interesting to work with this because it seems that the downward movement of the weights inside creates, of course, a force that is working in direction of gravity, so onto Earth. And this energy that I lose here for Earth pressure, I maybe can also use for explaining the difference, or more or less to explain why at the end we have this forward movement. Let me switch now to a first sketch that I made because this principle, oh no, not a sketch, sorry, to the proof of concept I made because this solution looks very nice, but I tried the same by myself, and I go to the second video. So this construction is made of plastic bricks you maybe already know very well, and now I'm spinning up here the mechanism, which has here a spring and a little wire. And this mechanism turns these pendulums which has also the weights at the end. And you see the two cards. So the upper card is now pushing against the lower card, and this brings movement to the left. Because the floor could also have an inclination which might affect this movement, I also tried the same experiment to the other direction. So now I'm preparing the card to go to the right. And so by this, I can I can make sure that it's not based on the surface. You see also here the card is standing on a plastic plate, so that friction between the wheels and the surface is as low as possible. And now we start. So last seconds of the second trial in the other direction. And here it goes. So you see, we have a movement to the right. And it looks like it did before in the historic video. So we have this stepwise movements, um, and of course we have the inner card that is moving inside the outer card, and we have here of course the inclination. So we have the inclination of the two contra-rotating pendulums. And of course, we have slight inclination of the lower car, so that I can make sure that the inner car is moving to the right side here in this case. Why is this movement? So we could think about, yeah, there is some friction here around the wheels. It could also be that this inner movements, which has also a less friction because of the inner wheels that are rolling here on the surface, um, is yeah, somehow disconnected from the lower card. And for this reason, I can build up a force in the upper card and release this force to the lower card, which is then transferred in the movement and overcoming the friction of these wheels. So this is more or less what you can say if you want to have a conservative view, which for sure from a physical standpoint is correct. But anyway, I try to improve this. And the next step is for me to see if I can make a construction that connects these two components, so the lower card and the upper card, into one single component that you can move around and that you can, of course, imaginative bring into space. Because this part, if you bring it into space, it's falling apart and nothing will happen. Yeah, maybe the upper card will rotate due to the movements of the pendulums, but nothing else will happen. So let me try now to make a sketch for you. So just a second. So first of all, move away my mouse. First of all, let's say this here is the Earth surface. So let's draw here a little Earth. All right. Here is one wheel, and here comes a second wheel. These two wheels are connected, of course, with a body, which is the card. And on the card, we have a center axis. And at the top of this axis, a pendulum is mounted that is moving forward. So now here I make this pendulum here in the forward direction. And you see I draw it with an inclination. So the upper mass of the pendulum is higher. And the lower mass is, of course, below it. And here the distance, the pendulum is overcoming by gravity. So there's no motor. If I release it in the upper position, then it falls down to the front. And this creates for the card a reverse movement. And when the pendulum is in the front, the pendulum creates a movement in the front because the masses are moving against each other. So if the pendulum is moving forward, the card is moving backwards and vice versa. So just let me draw it to the end. Then I'll explain this chart at the end. So, okay, pick up my mouse here. So if the pendulum is going forward, then the card is moving backward, and then the swing is continuing, and the pendulum goes back again to the rear position. And of course, the card is then moving forward because the masses are now moving against each other in the different direction. What is also interesting here in this picture is that the pendulums should start and end at the rear position in the same height. So I try to create a force. Maybe or what I did is I put in here at the beginning a little spring that is accelerating in a start point the pendulum very slightly. But then at the end, after maybe 10 degrees or so, the pendulum is really free falling. And here at the front of the card, it has a lot of motion energy because it swings in the lower position and swings over, and then it goes back to the upper position. And now it comes what I found out, because you might think, okay, if you move this mass to the front and move it back, and the car is moving against this motion, so this means at the first it moves backwards and then again it moves forwards, but it should stand still, right? So after these two motions, the masses are again in the first position, and so nothing should happen. But I found out that this front swing here creates another additional force. And this additional force is something like a swing motion. So the motion here, because it's so high, forces the car to move further to the right. And so even if these two movements, the rear movement and the normal mass-related movements in the forward is neutralizing, there is one movement portion remaining that brings the card to a rolling movement to the right. And this I can show you now with two little videos which I made from a card like this that I made in reality. So the first video, you will see this card moving to the right. Just give me a second. Maybe I drop down a bit the noise. So once again, you saw what happened. Just let me bring my pointer. So the card at the beginning was standing here at this coin. So the coin is more or less my starting point. The card has four wheels. So you see here these little ends of the axle are ball bearings, which are moving very, very easily. And it's standing here on this flat surface, which is made of a polished stone. Then you have here in the middle the center axis, and you have here the swinging arm. And at the end of the swinging arm, I put a mass that is more or less a trial mass. Yeah, so I tried out what works best. And this, of course, is a special relation between the swing arm and the mass here and the mass of the card. So both I adjusted accordingly. And also here, it's not so easy to see. Here is an inclination. So the right position of the pendulum is an upper position, and the front position here of the pendulum is a lower position. And the difference, I don't know it exactly, but it's more or less 2 or 3 centimeters. So it's not so much, but it's okay because here the mounting of this pendulum is also based on a ball bearing, and it's very easy for it to fall down. What you see here also in the upper area of the card is a catching mechanism. So when the pendulum comes back to the upper position, it just catches it so that it remains in this position. And so I have an ending point where I can compare the starting point with the ending point. So now let me maybe restart it for you. And if you like, you can watch here the coin and the wheel in the upper position of the coin, because then you can see what we said before. First, it does a backwards movement, and then it starts moving forward, but it's moving much faster in the forward direction. So let's see. And it's also interesting that the position of this pendulum in the rear position is the same than before. As I said, so I put in here a little spring so that there is a little force that it's driving it forward at the beginning. But then here in the front, it's totally free rotating. So it's just the motion from gravity that it's increasing the weight here and the movement of the arm. And so with this little extra plus, or with this little surplus of energy, it reaches again this upper position. Sorry. So what's next? You can, of course, try this in a different direction. So this is what I did next, because also here it could be that we have an inclined surface, and I tried it also in the different direction. Just let me show you this. You see, we have more or less the same effect. So this is the same configuration than before. We have the coin here. We see this is the movement that we reached, more or less on Earth. And of course, we have here the swinging arm in the resting position after the swing. I started a second time. And clearly it does the same movement. So first it goes back and then it goes to the front. Last time it goes back and then it goes to the front. And you see the front movement is much more intensive than the backwards movement, which is clear because the force at the beginning is very low. So the starting movement of the pendulum is yeah, not so strong. And here, if we have the front swing, the motion is much higher. And so if you do this mass braking maneuver by swinging down, the whole mass plus the energy it has is going into the forward movement. And when it's coming up again, the movement is going less and less, so until it stops. And then the movement, of course, is also reduced of the card. So what can we learn from this view or from this experiment? First of all, we reached a solution with this inclined pendulum that is connecting the two movements that are the two components we saw before in the card experiment with the two cards. So here we have one component which is connected totally, and it's standing on the earth, and it reaches a forward movement with this pendulum. Um, of course, if you put this in space, nothing again will happen. Yeah, so at least if this spring would not be, nothing will be. So there's no forward movement. And even if you put in here a motor or something that it's moving it nothing will happen again. So it will turn around on the point where it is. So there's no movement forward because it's necessary here to have a gravity and maybe this friction that is created here from these little wheels, so that the build-up of this movement can be created with a friction related, yeah, constraint. But when we release the high motion in the front of the card, then the friction is overcome and the card is moving forward. What is interesting as well is if you have this pendulum starting point at the same position, you can also imagine that you have a forward and backward movement. So if you put a motor on it and you make the movement of the pendulum going to both directions, you can have a continuous movement of the pendulum, and the card should move, as we saw in the initial video, should move piece by piece to the left side. So we reached with this construction something that is replacing the first solution with the two cards, but something that is not really working in space. But I did not stop in this moment, and I tried another experiment, which again improves this construction. And I tried tried to find what is really bringing forward this card. So this front swing was interesting for me. And now let me give you an overview on the next experiment. This is more or less a hanging construction. So I removed here fully the wheels, and I hang this on two cables that are coming from the ceiling. And through the cables, I was able to provide some electric energy. And inside this construction, there's a little motor. And this motor is, of course, driving the pendulums that are mounted on it. Um, The idea is again to move this construction to the left side, so we are still in a horizontal approach to propel this. And you see also the inclination. So this construction has an inclination to the left side. So the pendulums that are mounted on it should fall from the upper position to the lower position at the left side, and it should create a swing force at the left side. At the end of the pendulums, you see here, I also mounted a weight, and I also mounted a weight on the whole construction because I found out with the rotation that it makes, it's good to have something like a counterweight that the movement of the whole construction is not so high. Then what you see as well is there are two pendulums mounted on each axle. So the upper axle here you see has a front pendulum, has an end pendulum, and here now the video moves upwards. So you see also here the upper fixture of the two cables, and this is in parallel, of course. And when you go down, then you see again the whole construction hanging there. And you see that there are these two pendulums. And in the middle of the pendulums, we have something like a construction that holds these pendulums in a position or allows them to rotate here around two axles. So here we have the axle for one pendulum, and here we have the axle for the other pendulum. And this whole pendulum mounting is driven by the center axis that comes out here. So more or less, if it's rotating, then this upper pendulum can fall down, and the lower pendulum first swings by the front and is then catched by a catching mechanism here at the center and is then taken over the upper point again, so that it can fall down as next in the second round. So more or less, with these two pendulums, we can create a forward movement or not a forward movement, we can create a continuous movement around the center axis. And always we can have a falling pendulum, and after it swings, after it is going the front, then we can bring it back again with a slower movement to the upper position where it falls over and can go down again. What in addition? So I also found out that if you have this single pendulum construction at the top, it creates a lot of rotation forces. So the motor in the middle here in this center body is really pushing against this upper pendulum pair. And the construction is rotating by this. So it's like an helicopter. So if you rotate the upper parts, then the parts below will rotate contrawise. And this is the reason why I made also a pair of pendulums at the lower end of this construction. Just let me restart the video. So here you can see the lower two pendulums, and these are rotating contrawise. So I tried with this contrawise rotation to neutralize the movement of the upper pair of pendulums. And so with these four pendulums, I reached more or less a more stable rotation movement, and the movement of the whole construction was not so high. Interesting as well is in the background you see here a wooden plate with a line on it, which is my center point when it comes to the when it comes to the measurements. I want to know, is there a movement to the left side? And I used here the center axis. So you see this knob where the pendulum mounting is fixed. So we have the same here at the lower end. So here, and this center knob is my mark that I compare with the plate in the background, so that you can see if it's a forward, backward, or pendulum movement that the object does. Now let's start with the experiment. I go to the next video. You see that I put in here a red line in the middle. And this red line is what I said before. So this is my center line, and it's matching. I just restarted a second time. It's matching here in this rest position with the center knob. And what you see at the moment, it's really a free hanging object. It's more or less free centered, and also very interesting and important. The pendulums are in a resting position. Two of them are in the front, and the other two are in the rear of the object, so that there is no mass shifting forward or backward. So it's really a neutral zero position in which this object hangs. And when we start here the movement, you see now these pendulums are not really moving smoothly because we start with a low my information, so 5 volts at the moment. And this is not enough to spin up the two pendulums. So you see the gears are working hardly against the friction and against the gravity forces of these pendulums. But if I hold it in the front, then it comes to a better movement. And so this is something I did from time to time. So I saw that the construction is moving too much, and then I hold it for a while, and then when it's blown up and it's really rotating as I expected, and then I let it go. Just a second. Let me use just some words for comments. So if you like to write into the chat for discussion, feel free. So what I'm describing here is really imaginative. It's a fictive drive, yeah. So I just made some experiments. I want to explain what I saw, my findings. But yeah, it's something I play on in parallel to my regular work. And so I hope you enjoyed. Feel free to write a comment if you like. And yeah, it's my first stream, so this is something I'm learning. Let's see how we can continue. So now we are at 5.5 volts. So I registered. We need more power, and it's turning, turning, turning. What we are looking here is a time-lapse video. So I did not make a normal video because the movements of these pendulums is so fast, and if you want to analyze the movement, it's necessary to have a time lapse. And every 10 seconds you see here refers to 2.5 seconds in reality. So with 5.5 volts, the rotation is much better now. I put my mouse pointer here at this position because this is more or less the starting point, yeah. So, and what is interesting, if you watch this position in comparison with the knob, you see it's moving to the left. Not permanently, but you see it has sometimes the tension to go to the left, and then it comes back to the center line. But what it does not is it does not move to the right side of this line. So its maximum crosses it a bit, but it goes more to the left. Yeah, so I would say if I compare the measurement here, I would say it's maybe 1 centimeter to the left and maximum 2 millimeters to the right. And this is an effect that we will now see more and more with depending on the power we put on this object. So the faster the pendulums are rotating, the more force they are creating that brings this object to the left side. You can also watch the pendulums if you like, because you see they are falling down, swing by the front of this object, and then at a quarter of the movement, the catching mechanism picks them up and brings them again to the high position where it can fall down for the next time. So yeah, the movement is not so high, so the spinning speed is not so high, and for this reason, the whole construction is not so stable. Yeah, so it holds this steady movement for some seconds, and then it starts swinging, rotating, and then I catch it up for a second time. But this will be better in the higher speed region. So let's see what we can reach with this 5.5 volts. Now 6 volts, okay, perfect. It's turning again, so I think I have to catch it. But clearly, if you watch it, it always goes to the right side. Yeah? And this is something that makes me thinking, why is it like that? So, of course, it should be caused with the pendulums. I thought about drag from the air that is surrounding it, but the pendulums are really, really small, so thin. And you see they are moving, of course, in both directions, in forward and backward movements. And so the drag of the air we can ignore. So it's not a propeller or something like this. So it's really the masses that we are moving here. And this is causing clearly a trend of movement to the left. What I tried as well is to to make it sure that my neutral point is correct. Yeah, so I played with the pendulums and to see if it changes the neutral point of this construction. And so I found out if I put it in both directions, both pendulums, so that they are equally in a resting position, then you have really the center point of movement. And you see again, so it's moving to the left. But I think we have to put on more power. Cheers, my friends. Okay, next test. Sometimes I hold it more in front of this line, but then I release it very carefully so that the center point is again reached. So now you see we are again in a centered position. And now I put my hand away. Take hand away. So you see we have more or less a centimeter. The center knob is moving to the left side, comes back to the center, and then it moves again to the left side. No movement to the right side, which is wild. Once again, I let it spin up. And you can also recognize that the rotation is now faster than in the beginning. So of course, the increasing voltage causes higher rotation speed. You see, it's moving to the left. Of course, the object itself is also turning a bit, but it's turning mostly around the center axis that we are watching now. And for this reason, yeah, it's not a big deviation. So if you look at in an average, we stick on the left side with this axle. So I think now is the moment where I increase the voltage again. Yep, we are at 6.5 volts. And I catch it for the next trial. You see now the spinning speed is much higher, so it's coming to a more and more to a higher energy level. And now you see again we have this little movement to the left, not so high than before, and this is an effect that I also have to discuss with you, because when I spin up these pendulums too much, you can imagine that the centrifugal force of these pendulums is creating no longer a falling effect of them. So they will be just stay at the outside, and you will have something like yeah, not a propeller, but something like a spinning bar, and this will create nothing. So the effect comes from this falling movement. So if the pendulum is really falling along the inclination, and as long as we have this movement, you see that we have a force that creates a forward movement of this object to the left side. The effect is higher if the voltage is lower. Why is it like that? Because if you have a lower voltage, the pendulum can fall much better than if you have a higher voltage, because then the pendulums are driven through the whole swing that it has in the front, and then the effect is not so high. And you will see this as next. So if you remember the first distance that we created with this forward force, and now you see we are closer to the center line. So the force is now reducing a bit. And this is something that I found out. So the rotation speed is really also relevant for the effectiveness of this object, of this drive. So if you rotate it too fast, then it will do nothing. And if you rotate it too slow, then you will have a lot of other movements. Yeah, so it's not so stable in this case. So you have to find the right balance. And for in this case, I thought, okay, between 6 and 6.5 volts was the best solution that created more or less the best force to the left side that we saw before. Now it's again a good movement, but only for a moment, then it comes back to the center and so on. So it looks not bad, but it could be better. And this brought me to the next improvement of this machine, because as long as we are depending on Earth gravity to bring down the pendulum with this inclination, as long we are limited with the energy that we can take out of this construction, because the gravity has a specific force, and independently how good your bearings are and something, there is a limit how fast these pendulums can fall down. And of course, if you have an increase of this pendulum speed based on gravity, you can only create a horizontal force. So the pendulums have to fall down, and this does not work if you put them in free space, for example. And it does not work, especially if you want to create a vertical force. Because if you turn this object by 90 degrees and you want to make a force that is acting upwards, it will not work. So nothing happens. It's clear, I think. So what I did as next is I tried to replace the gravity. And maybe you registered the name of this live event is Centrifugal-Mass engine. The masses we already spoke about, so these are my rotating pendulums with the masses on them. But the centrifugal force is now the next part that I'm bringing into these experiments. So what I would like to do is that I want to push the pendulums to the lower position based on centrifugal force. And for this reason, I made a new construction. Just let me switch over to the next screen, which is this one. This construction, more or less, is mounted on a balance. You see here the front end of the balance. Here in the middle of the balance, we have also ball bearings, And in the rear side, we have again a bar for the balance with some counterweights. And so at the moment, as you see here in this picture, the starting point of the balance is in a vertical position. And the movement of the balance is very, very easy. So it just takes a little wind, and then it moves up and down. But here, of course, in my little laboratory, we have no winds, and for this reason, it stands still, of course. And here on the right side of the balance, we have now mounted in the center something like a triangle. This triangle is mounted on a vertical axis that you can see here, and a little motor at the top of this axis is turning this triangle to a rotation. Of course, if we have this rotation, we will create a centrifugal force to the outside. So here in the picture, we will have a force reacting on the right side and of course on the left side. And you see also that we have here at the side from this triangle axes that are coming out from it. And at the end of this axis, we have again the mounting of the pendulums. So we have the center head for the pendulum mounting, and at the head, we have to each side a pendulum hanging, also having a weight on this. And as before in the previous experiment, we see later that also these pendulums are rotating. So they are contra-rotating. So this one is spinning clockwise. The left one is spinning counterclockwise. And so what we can do here with this experiment is to try out if a centrifugal force is able to replace the gravity that we used before. If you imagine this in a rotating movement, and we have this inclination provided by the center triangle, then the pendulums will move upwards because the centrifugal force will push them to the outer side, and because of the inclination, this pendulum will be driven to an upward position. And if this is in a high rotation speed, you will have more or less the same effect that we had before with gravity. So the pendulum will swing up, will then overpass the top position, and will then again go down, lowering its speed. And then a little mechanism here at the head of the pendulum mounting will then push it over the lower position so that it can fall, in parentheses, can fall back to the upper position. So more or less what this pendulum construction does is more what we saw before, only that we now have this mounting on a vertical construction, and the force that we are expecting now is a vertical force that should be in an upper direction. I tried to measure, of course, this movement. So you see here at the lower end of this mounting a little white bar, and this is in front here of a meter. And here you can read then in the background at what position this bar is. And you see also here this black box. So this is a volt and an ampere meter. So I was rid of showing papers in the camera, and so we can see directly what was the voltage and the power and the current we invested in this movement. And now we can start. So let's see what happens if we rotate this construction. So I go to the experiment. This is the starting point. So it's now here. Also, we have a red bar. You see the 0 line. So from this we started. And you see also here that we have some voltage now, close to 4 volts. And the rotation is already starting. Yeah? So the pendulums are falling at the moment because the gravity is higher than my centrifugal force that I try to create. And with the increasing speed of this center triangle and the increasing centrifugal force we create to the outer side, you see that the pendulums are starting to move upwards. Clear, yeah? So the inclination here is like we saw before, the inclination on Earth, and the centrifugal force pushes the pendulums to the outside. And by increasing speed now, we have more or less an effect that is comparable to the previous experiment. So we have a pendulum that is increasing speed to the upper side, is then swinging by the upper position and goes down back, slows down, and ends its movement here at the lower side. With the two pendulums mounted, it should be at the end a continuous movement. And with the two pendulums pairs, so at both sides of the triangle, we should also have a neutralizing motion, so that the center is not yeah, it's not so hard affected with this contra-rotating pendulum movements. But anyway, if you watch the balance here, sometimes it's shaking. Yeah? So really the forces we are creating here are very high. And for this reason, also the pendulum movement is not so smooth as I expected. You see here a time lapse. So again, we have 10 seconds are respecting 2.5 seconds in reality. But nevertheless, even with this time-lapse movement, you see that the pendulums are so fast that you cannot follow them easily. And so I tried in one case piece by piece. Yeah, so I used the video editor and watched each single pendulum, how it moved, and of course, I tried out what is the effect of this movement, especially if you watch here this white bar in comparison to our 0 point, zero line. So you see sometimes it goes up, sometimes it's also below the center line, which for me indicates, okay, we do not have a real force that is pushing upwards. So as long as we are going up above the line and below the line, it means that we have something like a swinging motion, yeah, something like a wave movement. And yeah, it's interesting to watch, but it's really hard to understand what is going on. At the beginning, I found, okay, there are phases where you see that this movement is really as I expected. Yeah, so we have this swinging pendulums, so they are really swinging at the upper end. But then a few seconds later, it's again not really regular movement. It's shaking. It stops the movement. So here I have to improve something. Yeah, clear. So the basic construction maybe is interesting, but the movement itself is not stable. In the meanwhile, we see that we are at 8 volts. So really the forces are increasing and increasing. The shaking movements of the balance are increasing as well. Um, and I thought that we saw the best results at, yeah, maybe 6 or 7 volts, where we had really phases where this was a good movement. But again, now we have also phase where you see here in front, we have the upswinging pendulums. Now. And yeah, so this is in some cases a good basis for further analysis. But it's not fine, or it's not enough to say, okay, I just watch videos and try to, yeah, to see if I can create an upward force. Clearly, if the balance is now going up and going maybe to a position that is leaving the camera, then I know it's working. But I tried something else because you see there's not a clear indicator what happens. So coming back to my physical knowledge, I know this movement cannot create a real force to the upward direction. Um, but it sometimes looks like that the bar remains in the upper position, but then sometimes it comes back to the lower, and of course it goes down as well. So it's not like in the experiment before where we had a movement only at one side. And so I made something that helped me a lot in this analysis, which is a scanner that analyzes the videos and gives me yeah, let's say objective information at what position this bar was in which moment. Yeah, so here now the experiment ended with a lot of question marks. Yeah, so was the movement correct? Was the or let's say was the movement of the pendulums correct? Was the movement of the bar in some cases indicating a force? And with these question marks, I tried my analysis. And just let me show you my scanner, which is more or less an Excel file. And this file has here a time scale. So I measured each second of this time-lapse video, of course, yeah, the position in centimeters. So I was able with this little tool to make a configuration so that I make just come back to the video. So I made here first the configuration that I saw, okay, where is the neutral point? And then starting from the neutral point, the tool further and further measured the position of the white bar so that I have something that is empiric. And this I can use for further analysis as well. And I did this also in my sheet calculation. So when I come back to my results, you see here, um, first of all, on the left side, this is my time data that I connected. You see here, of course, a gray area, which is more or less the gray area here in the chart. This is something that I identified as a center point, so not a specific line. So I thought it makes sense to have an area in which the scale, in which the balance can move. And I say, okay, there's no real force acting. But then you have here in the last row, in the last column, the vertical position, and this is changing over the time. Yeah. So as I said before, every second of this time-lapse video, I registered the position of this bar, and this data I then projected in this chart that you can see here. And you see we have here this gray wave. This is the movement of the bar itself. Yeah, so here on the left side you see the centimeters in which range it moved. And I again found this was not so easy to understand. And so I made an average by 10 that you can see here in the white dotted lines. And this white dotted line indicates me, okay, over this time that we are measuring, so even if it's a time-lapse video, time-lapse time more or less was 5 minutes that we saw. And you have here areas in which the red average line is above the center line. Yeah, so this dotted line in the middle is the center line that we identified at the beginning of the experiment as the neutral point. And it seems that it was in some cases more related to the upper position, especially here this red case, this red box. I found out, okay, we have here more or less from 2 seconds to 3 seconds 12. We had a slow time where it was really in an upper position. What I did as well, all these boxes I draw, um, had phases or represent phases where the movement of the pendulum was more or less as expected. So the pendulums were swinging up, were really creating a force, of course, and then were going down in both sides, so that it was a smooth movement as we expected. And this was then the moment where I said, okay, um, I analyzed this as much as possible. I know that the pendulums swing upwards, create a swinging force. I registered here in my analysis that there are some yeah, indications that we are above a center line. So this could maybe be a force that we also identified in the first experiment with the horizontal movement. Yeah, so we have also here an effect that we have in a short period of time, um, a movement that is pushing up the 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 the, the balance. Um, yeah, and this brings me now to the point where I say this is a point of discussion. Yeah, so knowing that in general such such construction will not create a vertical force. You see that we have here an empirical data that is indicating something else. Of course, what I have to try out in the future is also um, if there is something that influenced this movement in addition. Yeah, I know here was no wind in the room. Um, Maybe it's something I have to change in the configuration of the balance. So maybe the center point of the balance is not perfectly adjusted so that we are a bit too low at the beginning, and then the center line could also be here. But but if you increase the center line, let's say we rise it by yeah half a centimeter, so that we have it here, then again having this first part is moving around the center line. But if I'm here in this red box and the center line is also here in this raised position, then once again, the average movement is slightly above the center line. Not so much, but slightly above the center line. And this brings me now more or less to the end of the today presentation. So feel free, of course, to rewind and to check um, what I showed you before. You see my experiments very detailed. So for me, it's important to share my knowledge with you. Yeah, just to foster this free thinking um, out of the box. So even if it's not possible, it's a lot of fun to play with such constructions. And anytime I switched it on and watched on it, I thought maybe it could create such a force that I expected. But okay, let's say at the moment it's a hobby. As I said, it's not serious for a real rocket science, so it's something like a playground that I'm playing on. But for me, it was now important not to do this by my own, but also to share this with you and to give you maybe also the chance to check what I made, to share your own thoughts, to make your own experiments, and so to also to create a cooperation, if you like. And let's see if there is something else I can communicate, if I make a further progress in this kind of propulsion. I will let you know, and maybe it's also a good possibility to make another live stream with you. So feel free, of course, also to check out my other publications, which I try to make more serious, of course. Sometimes it's good to be realistic and to have an evaluation based on what is state of the art and not in what could be in the future. And for this reason, of course, please take this as an example of free thinking and yeah, maybe as a mind experiment, so to say. So that comes to the end. I would like to thank you for your attention. So it was a pleasure for me to share something from the project here in my little room with you. Yeah, and let's see if we can meet each other in the future. Thank you very much. Take care and bye bye.